Today I'm going to be going over how to complete the Energy Skate Park PhET simulation for Miss Nagel's physical science class. This assignment should be linked on Canvas, and right beneath the link for this assignment is a link for the actual simulation itself. You will need a timer for this assignment. Again, as you can see here, the purpose is to see the relationship between kinetic and potential energy and how they relate to total energy, when in this case, we're going to start with conservative forces are present. We're going to take that data that you get and analyze it graphically to see a clear trend as to how kinetic, potential, and total energy relate. Okay, so go ahead and open up your Energy Skate Park. Once you get there, you should see this right here. You will need to click Intro. So you see there's a U-shaped ramp and then a skater here. Your assignment does tell you to make sure all boxes are checked. So if I go back and I check the pie chart, bar graph, grid, and speed, you'll notice that you really can't change the shape of that actual ramp right here, this U-shaped ramp or skate park. And if you also notice your skater here, it has a little red dot underneath of it. That's going to tell you exactly how high up on this ramp you are actually placing your skater. That's where your grid lines come in handy. It tells you exactly how high that is. So right here, that lines with a 6, so that'd be 6 meters. So as I let the skater go, you'll see go around the ramp and then come back up, all the way back up to 6, and before they come back down. Now to see how they relate and be able to take that data and graph it so we can analyze the trends, I'm going to go ahead and pause my skater. Okay. But as you pause your skater, you can kind of already see it does a little bit of it graphically for you. So I can kind of see a bar graph here, and I can look at how they switch back and forth. It also does it in a pie chart. But we're going to do a line graph. So I can see a little bit differently as versus time. So I come back to my assignment. It asks you a question about your bar graph and your pie graph. And then it tells me data, or at least establish a number system for both your speed and the mass. Because of course if you go back to the actual simulation, the simulation does not have that. So if you look, the long lines go by 2s, starting with 0, goes all the way up to 20. That means the little lines represent the 1s. For the mass, the small skater we're going to define as 5 kilograms. The large would be 15 kilograms, and right in the middle, right in between, is 10 kilograms. Now to collect the actual data, it tells me to place a 10 kilogram skater at 6 meters and start the timer when you hit play. Pause both timer and sim when the skater has the designated height. Record the height, which I've already done for you, speed and time in the table below. Continue until you've reached the end of the table. So let's go ahead and start this. So I take my 10 kilogram skaters, and again, it doesn't exactly tell me 10 kilograms, but we set up that in the very middle is 10. And I'm going to take my skater, I'm going to put my skater, that little red dot, right up here at the 6 meter line. And it tells me to go to the next height, which is 3 meters. So at 6 meters, I haven't started my timer. It's my time 0. And I look back here, my speed's 0. So he's not moving yet. Okay, so I'm going to go to 3 meters, and I need to record the speed and the time it takes to get to that point. So timer in hand, you're going to press start and play at the exact same time, or at least as close as you can get. So we're going to hit start and play at the same time until the skater gets to 3, which is going to be right here. So if I hit play and start, and I'm going to stop it close to 3 meters. Now if you're like me, I'm very bad at that hand-eye coordination. There is a slow-mo button. The slow-mo makes it a lot easier if you're not that great at hand-eye coordination. I pause the skater at exactly 3 meters. And since I know I'm going to need that slow motion button, I'm going to go ahead and start it now, because as it says, you're welcome to use slow motion, but make sure you are using slow motion the entire time. So I'm going to go ahead and help myself out here. I'm going to go ahead and reset my timer, pick up my skater, and put him back at 6. That's just to help me get better data, because I'm going to be able to stop it closer to 3 than, oh, oops, I went past. Hopefully that'll work. I want accurate data. I want the best data I can get. So slow motion is going to help me do that. So I'm going to hit restart my time. So now I'm back at 0. So again, I start at 0 seconds and 0 for velocity. So reset time 0, my speed's 0. So when I hit play and start until my skater gets to 3. Okay, so I got a lot more accurate this time than I did at normal speed. So I look back, I'm going to look at my timer. Whatever your timer states is going to go here. Your velocity. Now granted, it does not say velocity on your simulation, but that's your speed. Okay? Velocity is just speed with a direction. So we're going to go ahead and put our speed in here. Again, it starts at 0. The big lines go by 2. So 0, 2, 4, 6. Well, it's not quite to 8. Okay? This is where you need to get as accurate as you can be. Granted, there's not lines in between, so I can't tell exactly accurate. But I want you to get as close as you can. So to me, that's between 6 and 8, so there's 7. And it's kind of between 7 and 8. So I'd put 7.5 as my velocity to get to 3 meters. Now to get to 0, which is my next height, do not pick up your skater. You're trying to keep the same total energy and how it relates to each other over time as it goes down the ramp. So don't pick up your skater. You don't want to change the total energy. But also don't start your time over again. Your time should continue the entire time. It should never go down. It should always continue to increase. So do not hit reset on your timer and don't pick up your skater because you want to see how it changes over time, which means you can't reset your time. You just go the entire time the actual skater is going as well. So I'm going to continue my time and play until my skater gets to 0. If I do that, okay, very close to 0, closer than I'd be with normal speed. Okay, so I'm going to get my time, look at my timer, write the time down here, and now my velocity, I need to get again from my speedometer. So look, 0, 2, 4, 6, 8, 10, 11. So my skater's going 11 meters per second, so that'd be filled in here. But my next data point says 3 meters. Well, that was right here, and this skater's facing this way. Well, since this skater is on a U-shaped ramp, there's another 3 meters right here. So that means now instead of going for this 3 meters, since my skater is facing this direction, I'm going to go for this 3 meters. So again, don't pick up your skater because you want the same total energy and how it relates to kinetic and potential. And continue your time. Don't reset your time. So I continue and play until my skater gets to 3 meters. So I'm going to take that time, write it down at 3 meters, and I need to take my velocity. So I look, 0, 2, 4, 6. It's not quite to 8, and I can see very clearly that there's a line right here, that little white line you can kind of see. It's not 8. Again, it is very hard to get this because there's not specific lines. Get as accurate and as close to accurate as you can. Right? You're going to continue doing this because if you look, it goes back up to 6. So you're going to play and continue your time until your skater gets back up to 6. To me, this is the hardest one to do because I don't know the point in which it turns, and it's right here, it's at 6. And so I'll make energy backup potential, but I saw a little sliver, and kind of want to see right here, of green, which means technically they're not really up at 6, but it'll work. It's as close as I can get. It's as accurate as I can get. So I'm going to write my time down where it says 6, and I'm going to get my velocity. Again, it's not quite on that line. Get as accurate as you can. And then you're going to keep going. So if you notice, the skater is going to turn and come back down to 3. So again, you need to have your timer going. Once you hit play, get the time and the speed, write it down for 3, and you're going to keep going until you hit the end of this graph or this chart right here. But if you notice, right after the end of this chart, it says change the skater's mass to 5 kilograms. So I'm going to come back to my sim. So again, once you're done with that entire chart, you're going to come back. And now if you hit reset, this little arrow looks like it's chasing itself. You're going to click all 4 boxes. But now I want my mass to go down to small. That's now a 5 kilogram skater. So I put my skater here. Well, I haven't hit pause, which means they're automatically going to go. But if you notice, my total's a lot less. And so that now we're also looking at how mass plays a role in energy. Okay, so if I press pause because I don't want to have to chase the skater down, I'm going to place that red dot at 6. Again, I know I'm going to have to do it beforehand to make it easier on myself, I'm going to go ahead and click slow motion. Okay, you do want to reset your timer back to 0, okay, because you got a new mass and skater. So I'm going to reset that time to 0, and if I look, the skater speed should be 0, and it is. So I'm going to start my timer over, make sure it's starting at 0, hit play and start at the same time until my skater gets to 3. So it's the exact same process. Okay, so you're going to write your timer down, time down for 5, and again, 0, 2, 4, 6, get as close and as accurate as you can. You're going to do it for 5 kilograms, exact same way, and you're going to go 15. Again, 15 kilograms is, if I reset, get all my boxes checked, it is your large skater. And again, if you notice when I put them on here, the energy changes. Okay, you can see a lot bigger of a pie graph here. You can also see a lot bigger of a totaled one here. Once you have all of your data for your 10, 5, and 15 kilogram skaters, we're going to turn that into graphable data for energy. Okay, so it says time, potential energy, kinetic energy, and total. So time, just copy down as is. Be very, very careful and mindful to not forget these zeros. Those are data points even though they're typed in. Okay, so that means your potential energy, again, don't forget those little typed in ones right here. Potential energy, if you look in your notes, is mass times gravity times height. Well, for the first scenario, they told me a 10 kilogram skater. So mass is 10 for that first scenario. And I've actually separated them here so you can kind of see where they are, where those different masses are. So it's 10 for the mass times gravity. Well, I scroll up, this is an Earth skater system. Well, here on Earth, my gravity is 9.8. So it's going to be 10 for the mass times 9.8 for gravity times your height. So I look, it's either going to be 6, 3, or 0. Okay, so you'll notice a very clear pattern as you start making your potential energy or calculating your potential energy. Kinetic energy has a very different formula because again it's the energy of motion. It is 1/2 times mass times velocity squared. So in this case 1/2 times 10 times your velocity squared. You can do that one of two ways. Either in your calculator, you can find the squared button and type in this case, my first data point here is 0. So I type in 1/2 or 0.5 times 10 times 0 squared. Please make sure that just the velocity is squared. That means you're going to have to use parentheses in a graphing calculator or hit equals in between on your phone if you're using your phone as a calculator. The other option, if you don't have a square button or you cannot find it, all you have to do is multiply it by itself. So I would take 1/2, 0.5, times 10, times 0, times 0. So you multiply it twice to get it squared. That'll get you kinetic energy. Total energy is probably the easiest of the energies to find. All you have to do is add potential and kinetic energy. Once you have your data, you're ready to start graphing.